Okay, so we are in this chapter of basic programming concepts. So far what we have seen is bullet number 1, and in bullet number 2 we have seen up to 2.6. We just started 2.6 in the last class. So today we'll cover this last topic, and then we'll move to the visualization, and hopefully we might be able to cover at least the first example, or maybe the entire chapter. Let us see. So before we proceed, let us quickly revise what we have seen in the last class. In the last class, we have seen the concept of data frame slicing, sorting, and selecting. Okay, sorting and selecting, and yeah, that's where we completed them. This one we just started, and also the accessing element. That's from where we started in the last class. So these are all the topics that we covered in the last class. Most of the topics here are based on this concept that when you have a data frame, you have two styles to access the elements, and those elements could be used for slicing and and for other stuff as well. So this is like indexing, how we can use indexing for the data frame. There are two styles. Do you remember what are those two styles, guys, in the class? Do you remember what are the two styles of accessing the elements of a data frame? No.
Look and I look.
That's good. So you have one I lock, the other one is lock. Uh, and then it is single square bracket with comma where you give the details. So now tell me what's the difference between lock and iLock. What is iLock and how is it different from lock?
I look is
I look use
indexes.
the indexes.
Okay, so when you say iLock, basically it is the index. Okay, index locations. Yes, that's right, Hamza. Okay, it uses the indexed locations. So what are the index locations? Well, for any array or even for the list, you start with 0 and then it goes on. Okay, so that is the indexed location. Whereas the lock, that's right, lock is the named location. Okay, lock is the named location. So these are the names. So every data frame, if you see, it has some column labels and it has also some row labels. Okay, and the column labels are called as just column headers or headers. The row label in data frame are called as index. So that is something I just want you to be careful with. Yes, this is the index, which is the index of the list, which is the index of the array, or the same thing continued here. This index for the data frame is the row labels. Okay, the row labels. So these are two different. Of course, I don't know why they are using the same wordings, but be careful with that. When for a data frame, the index means the row labels. But when we say index here, it is not the row labels. It is the index in the sense of uh, 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 index of an array or index of a list. Okay, so that is something to remember. Now, when we are doing the slicing for using the iLock or lock, there is a small difference. There is a small difference, especially the difference is in this no style. So you remember, right? When you have such inputs where you have the input of the rows and columns, you could provide whether start, end, and step type of input, or what else can you provide? So when you have
List.
such input, yeah, a list of indices. Okay, list of. Okay. Similarly, here for the location, you could also provide, let us say, start. Okay, maybe. Yeah, I think that uses start and step, or also the masked list. Okay, the masked list. That is not clear. Let me write it again. Masked list, which is the list of booleans. Okay, list of booleans. So, well, this is of course mass list. Okay, with lock. Also, there's a difference here. Can anybody tell me what is the difference?
It's
Oh, when you give
inclusive.
it like this star. Yes. So this end is inclusive because it's a named location. End here is inclusive, and end here is not inclusive. So that is something we must remember. Okay. And again, which one is the best? There's nothing like that. You have to look at the scenario, and for a given information, for a given scenario, this could be easy, or the other one could be easy. There used to be, I believe now it is gone, but there used to be a hybrid of these two. And one you could have index, the other one could be named location. There used to be a hybrid way. I think it was like data frame dot xs something, but they stopped. I think Python discarded it a couple of versions back. Okay. But there used to be a hybrid as well, and that hybrid was creating confusions. Okay, so it was discarded. So yes, these are the two ways in which you can do the access the elements, do the slicing, and also selecting. In selecting, basically this is the idea. Let me highlight it here. Selecting is basically here. Okay. Sometimes you would like to select some specific rows based on some conditions. So what you do is you simply create a masked list. Okay, you create a masked list, and that mask you write it here. That will select only those rows. So that is the concept of selection. You are selecting some uh, list based on the conditions, and conditions are very easy, like the numpy conditions. You have condition based on the column. So the condition straightforward. It's like this: data frame for that column, and whatever is your condition, greater than or equal to, less than or equal to, or same as, and then the value, whatever value you have. Okay, so you have anything, and of course these are all the conditional operators, and then the value here. So using this, you can get the conditions for each column. And if you want to combine the conditions of multiple column, you can do that. For example, this is, let's say, condition 1. You want to use AND operator, you could have condition 2. And all of this, you could combine them again. And maybe you want to have an OR operator, you could have that. So you could have a complex condition, and usually complex condition is broken down into simple conditions and or OR operators. Okay, and this and or, when you have the array, you want to do the element wise comparison. That's the and that's the or operator. Okay, this is the ampersand. Okay, and this is the I don't know this what is the symbol. This is the vertical line. You can say set separator. And then finally, we have also seen data frame sorting. Sorting is also possible to be done based on values of values in a column, or based on the index. Okay, sorting can also be done. This is possible. It can be done based on the values, based on the index. In the slides, we are looking at the values, but maybe later on we'll also see how to sort based on the index. When you have to sort based on the values, you could have a single column, or you could have multiple columns. Okay, and how do you sort that? This is a method, data frame dot sort values. Okay, and if you are sorting by single column, it's very straightforward. But when you have multiple columns, you need to have some preference, which column should be preferred and which column should come next. So if you have multiple columns, a preference is given, and that preference is usually given as an input in the order of the way you write the columns. So you say sort values by, and then here you give the order of the columns. Let's say C1, C2, C3. It means 1 is important, then 2. 1 is preferred to 2, and 2 is preferred to 3. Okay. If you give 3 to 1, then 3 is preferred to 2, and 2 is preferred to 1. So that whenever you have multiple columns, there is a preference that is given. Okay. And just just very end of the class, we started this, and what we did, we have seen how to count the rows and columns of data frame. There are many styles to count the rows and columns, but one of the simple style is to use the data frame dot index. Data frame dot index, this data frame dot index will give you this array of all the indices. By the way, again, please, the index of a data frame is different from the index location. This index is different and this index is different. I don't know why this naming is used, but please be careful when we say data frame index and the index of the uh, list. It's slightly different. Okay, index of the list, usually in index of the list or array, they always start with 0. They are all unique. And the index of the data frame, it is not that index. It is not always going to start with 0. It could be anything. It may not be unique, so you have to be careful. Okay, so data frame dot index will give you this array of all the index labels, and then len, or the length of this, will give you the number of rows. Similarly, you also have another one, which is the data frame dot columns, and the data frame dot columns will give you the name list containing the column labels. So data frame dot index will give you the list containing the index labels or the row labels, and data frame dot columns will give you the index, will give you a list or array, will give you an array of all the column labels, and the len of this will give you the number of columns. You also have a method called data frame dot count. Data frame dot count, what will it do? It will give you the number of anybody remembers? Well, we did very close to the end of the class. It will give you the number of non-null values. Okay, yes, that's right. Okay, number of non-null values. So in a data frame, you could have some missing values, some empty cells. So it will tell for each column how many cells are not empty, how many cells are not empty. If you want to know how many cells are empty, the opposite of that, then you could say data frame dot is NA. Is NA will give you where the empty cells are. Is NA will give you a true or false, where true corresponds to when the cell is empty, false corresponds to it's not empty. Okay, so data frame dot is NA dot sum will give you for each column how many empty values you have. So this is to get the empty values, this is to get the non-empty values. So that is something you should remember. And this data frame index column and dot count dot is NA, and also there are some more methods that we should remember. For example, like data frame dot describe. What can we get from the dot describe?
The summary.
Yeah, the statistical summary, and giving the arguments, you could get different statistical summaries. By default, it will give you for numerical. If you want all, you say here include all. If you want only categorical, a shortcut is you just say here include object, and then it will give you only for categorical. And we have seen also some styles. In the slide, we have seen a longer style, but that longer style is useful, and you'll see why it's useful in the plotting. Okay. All right, and then also you have data frame dot info. Data frame dot info will tell you for each column what is the data type in Python. Data type in Python that is recognized in Python. Okay. So these are the usual things you do when you read the data to make sure that the data is read correctly. Okay. And there was also one more, data frame dot select data types. Do you remember what was the purpose of this? Select data types, data frame dot select d types.
Yes, doctor. This is the one for
Anybody?
the objects to select the categorical data.
Yeah, not only categorical. Yes, we use to select the categorical data, but select data types can be used to select from the data frame those columns for a given data type. For example, you could say here select data type, and here you could say include you could say here, for example, int. So it will select all the columns which are integer. Okay, you could say select data types, for example, object, and then it will give you all the columns which are object. You could say select data type floats, You could say select data types numeric and all numbers, and then you get all the integers and floats together. So any selection based on the data type can be done through this. Okay. So these are all the things that we have seen until the last class. It's just a summary of so many things. Do you have any questions, any comments? All right. So if you have no further questions, let us jump to the topic of today's class. So we have seen this is where we stopped in the last class, right? Now we look at the next important topic, which is the applying lambda functions. Now, many a times during the preparation phase of the data, when you get the data from some third party or from any source, or even if you collected the data, you might realize that you need to do certain things to the data to make it applicable for the next algorithm. And a simple things could be like the data looks like integer, but it should be categorical, or the data looks like, for example, string, but it should be integer, and things like that. Okay, and usually you do some basic things like rounding and formatting the data and things. So for those reasons, you can use one of the nice features that we have in data frame, which is to apply the lambda function. Okay, applying the lambda function. So you remember the lambda function. Okay, for example, if I say lambda x and I say, like, for example, round x, should be colon here. So what will this function do? This lambda function, but the lambda functions are nameless functions. They are anonymous. Okay, it will take x and it will round it. Okay, by the way, I think I'm making yeah. For example, if I give the input here, let's say 23.9. Okay, so it will give 24. If I give 23.1, it will give me 23. So it is just rounding. So our task here is to if I just reduce it, you see that it is asking us to take this column C1, C6, C11 and convert every number to the nearest integer. So it's not only asking you to do the rounding, but also to convert it to the integer. Round will not convert it to integer. You also need to do this int, and then something. Yeah, I missed a bracket. Yeah. So it will be now an integer value. Okay. So that's the lambda function. The good thing is you could apply the lambda function to the entire column. For example, I could say here data frame C1. Okay, and there is something. Yeah. Okay. So let us remove the int part. Yeah. So you can apply the lambda function to the entire column. For example, you see the value which corresponds to label 2 has now become 2, which is what it's supposed to be after rounding 2.1. Okay, but it might not work. For example, the int was creating an issue here. If I write here int, it was creating an issue. So a better way, or the way you do it in Python in pandas, is to do it like this: data frame dot apply. Okay, so data frame dot apply will apply this lambda function to all the elements, and this is the right way to do it. The other way you can do it, but it was not accepting the int for some reason. Okay, but okay, this is a typo. But now it accepts this. Okay, so the right way is to use the data frame, select the column, and then to that you use the method apply, and in the apply you can give any function. You can, in the next example we'll see how to give a generic function, but here I'm showing you how to use a lambda function. So lambda function, it could have usually when you use a single column, it means it has a single input, and for every element of that column it will perform this action. It will perform this simple action. Okay, now if you display the data, you see that here it didn't update. Okay, you see that here it didn't update. Now, can anybody tell me why? Anybody tell me the reason why it didn't update here?
Because it was temporary.
That's good. Yes, yes, that's the right direction. So there are many methods for a data frame, and we discussed this in the last class, that the methods, some of the methods are going to change permanently, and some of the methods are going to change temporarily. So that apply method, and actually, most of the methods in a data frame, they have this temporary thing, because changing it permanently by default is usually not done, because if you change permanently in the data frame, then it's gone. It will not be available anymore. So that's why these changes that are permanent are usually less, and temporary changes are more. So here this dot apply is like a temporary change. To make it permanent, okay, to make it permanent, what is the idea?
In place equal true.
Yeah. Now to make it permanent, some of the methods, temporary method, gives you this option of in place keyword. Okay, in place keyword. This is one way, and not all the methods has in place. That's the thing to remember. For example, a dot apply, it doesn't have the in place. So if this doesn't work, then the other approach to make a permanent change is to do the rebinding or reassigning. Okay, you can say rebinding or reassigning. What I mean by reassigning, I would just say here data frame column 1 equals to this. So what I'm doing is I'm taking the the column C1, and then I'm assigning the values. I'm reassigning the values. Okay, and these values are coming from here. So either some of the methods, they give in place equals to true, and some of them gives this, and everyone, actually all the methods can be done for this rebinding, reassigning for the data frame. Okay, sometimes you have to be careful, and maybe if you have both, I would prefer to go with the rebinding, reassigning. Okay, this maybe is better than in place, but again you have some nice flexibility. If you use in place, maybe you could use dot 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 multiple times operations. So how to check whether the method has in place uh, option or not, in place keyword or not? How to check that? Yeah, you use help. That's straightforward. Okay, and please get habituated to this. This will be very helpful, and you will find it is very useful during the exams. Okay, so here you see, you find that there is no in place equals option, so you cannot use. So then we are going to use rebinding or reassigning, and now you see that, where is it? Yeah, so this has gone to 2. Okay, so now it has changed in the data frame. Now this is for a single column, but let us say I want to do for multiple columns. What can I do? Well, one way is to just repeat it, which is acceptable, no doubt. Okay, and now you do it for 2 columns. C1 is done, C6 is done, or one idea. Oops, okay, I wanted just one. It's to use the apply map method. Okay, apply map method. So in apply map method, you could give multiple columns, and what it will do is it will apply for column 1, then the same method will be applied for column 6, so on and so forth. So in one single shot, by the way, I think this should be yeah, you cannot give, it should be like dot, let's say lock. Okay, dot lock, select more than one column. Yes, and I think this should be I cannot have so many commas, so they should be together in like a list or something. Yeah, Okay, and now it should work. Okay, so let me just bring it down here. Easy to read. So now I'm selecting that part of the data frame using the lock method. Why lock method? Why did I use the lock, not iLock? Anybody in the can tell me? Anybody in the class? Why did I use here dot lock? Yeah, because I have the names. Because I have the names here. Okay, that's it. And it applies for each column one by one, and you get the result. So you could repeat things, or you could use the compact way. Go with the compact way. Usually, compact way looks easy to actually not only to code but to read. For a reader, it will make it clear what you're trying to do. Here, it might not be clear. Okay, that's the thing. So that's it. So that's how we can use the lambda function to do changes. You could use the lambda function for one column using dot apply method, or you could use the lambda function for multiple columns using the apply map method. Okay. Any doubts? Any questions? All right. Now let us look at the next task. What it says is in column 12, he says there is some space between two words, and he wants us to replace the space by underscore. Let us print column 12. Let me, how about remove this, comment this, column 12. Okay, let me print here. So that's the column 12, and let us print some more values. You see, there are certain words, for example, below average, and maybe there's some more. How to know all the values? Well, you could do like this. How to know all the unique values of a column? Okay. The column name dot unique will give you the all unique values. So here you have average, below average, generous. So basically, he's saying that for the below average, no, the space, just remove this space by underscore. So let us say if you had a list, of such strings, and you would like to change, what method will you use in a string to replace the space with, let's say, some other symbol? How do you? Yeah, you have the replace method. Okay, string dot replace. That's right. Now I would like to use the string dot replace method not only for one string but all the elements of the list, all the elements of the array, actually all the elements of the array. And for data frame, if you want to execute any method for all the elements of the array, what's the approach? You use the apply lambda. For single column, apply lambda. For multiple column, apply map lambda. And what do you want to apply? So what is x here? X is the element of the column, which is this string. Okay, when you give this column, X will be this string, which is average, below average, generous, so on and so forth. So what do I want to do for X? I would like to say X dot replace, and what to replace? Space with underscore. Underscore is this symbol, right? I think we all know what underscore is. And now we could display column. And what is display ahead? Maybe. You can see that it has been changed. If you do the unique thing, you could see the unique now is also changed. Okay, so now the below average has been changed to below underscore average. So in this way, you could use any string functions and any functions that you learned in the prior classes, or even in the NumPy Python review chapter, and apply it for all the elements. So again, you don't need to do any loop. That's the thing to remember. You don't need any loop. You either use dot apply or dot apply map, and then you use the lambda functions, and straightforward things will be updated. Any questions, any comments, any doubts? All right. Now, there is a limit on the computation that you can do in one single line. Okay, lambda functions are good when you have things that can be joined in one single line. For example, I could say dot replace, dot replace, dot split, dot strip, dot capitalize. I could do dot 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 dot, and I could have a sequence of many operations in one line, and this is fine. In Python, this is very easy to do, and all those in one single line operations can be used in lambda function. That's it. But what if you cannot, let's say, write it in one line? How to do? Then it's easy also. You could have your generic function. You could have a generic function. For example, let us look at this here. Okay, here he says for column 2, 3, and 9, he's saying that round the values, not the usual round, but in a different style. The values nearest to 0 should be 0. The values nearest to 0.5 should be 0.5. The values nearest to 1 should be 1. So for example, if you have 0.4, what should it become? 0.5. If you have 0.2, how about 0.2?
0.
How about 0.7? Well, 0.7,
Should be 5.
it should be 0.5, okay? And anything like 0.8 or 0.9 should be 1. So you see, that's how you want to do the rounding, which is not the usual way. Maybe the usual round function will not work, okay? 0.25, yeah, you have to now decide where to put 0.25. You could make your own convention, and you could say that 0.25 or anything below that should be 0. So this is the place where maybe you can assume things, because this is not clear from the question. Should we include 0.5 or not? 0.25 or not? Okay. So 0.25, if we can assume it to be 0, or we can assume it to be 0.5. Okay. So here, this is a function actually. Let me copy this and let us comment all of this first for now. So that's the function. What it is doing, again, if the value is negative, which by the way is not there, but let's say if the value is negative, it will be returned as 0. Okay, the value is now converted to 0. Now I'm looking at the integer value of this x. Okay, if it is not negative, then I'm looking at the integer value of the x. And what I'm trying to do is I'm trying to see if the value is between 0 and 0.25, including 0.25. So this including 0.25, like I think Hassan was pointing out, it is not mentioned in the problem. So here you have to assume, and you can assume anything reasonable, and even you can write it here, in the cell, that this was not clear, so I could write it here that 0.25 is converted to 0. So this is something that you can assume and write it clearly in your answer, because not everything from the question will be very crisp. You will always have to have something to assume. Okay, this is a usual thing. So if you have such questions in the exam, which is things like this, which are not obvious, either you can ask the instructor, or you can write the comment that this is what you're assuming and proceed. But make sure that the assumption is reasonable. Okay? Make sure the assumption is logical. So this is what is being done here. You'll check the values, the integer value of x, which is what is int x? Int x is just, maybe let me show you. Okay, int 3.9. So this will give me 3. So it is like truncating. Okay, there's another word for it. It is like truncating the decimal part. So even if it is like this, it is truncating the decimal part. Okay, truncating the decimal part. So yes, cuts off. Maybe cuts off is usually we don't say cuts off. We say truncate. Okay, but one and the same. It is just removing everything after the decimal, whatever it is. It is like 0001, the same effect as this. Okay. Oh, this is, I think I reached the precision level. Okay. So yeah, there is a default precision level. If you hit that, then yeah. So be careful. So yeah, if you have 3.99, still it will take it as 3. Okay. All right. So here in this function, I wrote a small function that does this type of rounding. Okay. I just wanted. Oh, what did I do? I just wanted to have this function. So if I have 3. Let's say 7, it should give me 3.5. That is the nearest. Okay. So what it does, it takes the integer part, which is 3. And then to the 3, it is first checking whether the value 3.7 is less than 3.25. No. Then it will go here and check whether the value is more than 3.25 and less than or equal to 3.75. And this is yes. So what will it return? It will return 3 plus 0.5. If it fails these two conditions, then this is what it will return. This is one style of writing this function. You could have many styles, and the purpose is not to discuss the style of this function. The purpose is to show that if you have a function that takes a scalar, please remember this, it takes a single value, either a single string or a single number, integer or float. It takes a single element and do all the modifications and returns a single element. So if you have any such function that takes a single element and returns a single element, then you can use that function in your data frame to do modifications for each element of a column. For example, here for which column we want to do this, we want to do it for column C2 and C3 and C9. Okay. So here I'm using, we can do it one by one. Let us see for if I want to do it for one column, how would I do? We'll use just the apply method like we did before. And instead of lambda function, now I'm saying the custom round function. So what is the input? Input is every element of this column. And what will be the output? The output is the element that is given by this method. Okay. So now if I should have here data frame dot data frame dot head. Let's copy this from here. And the column we did is C2. So you can see in C2 the things have been modified. So exactly like lambda functions, here we can give custom functions. So now it is very generic. Lambda functions, yes, it is restricted to single line, and sometimes you cannot fit things in single line. Then just create your own single function. But what is the rule to remember? It's the function that you create should take in a single argument and returns a single argument. Okay, takes in a single argument and returns a single argument. That's it. And you could have any complex functions. You could have global variables and everything, and it could be as generic as possible. And if you want to do it for multiple columns, what do you think is the change? If you want to do it for multiple columns, anybody in the class?
Can't you add can't you add the lock and then from C2 to C something?
Yeah, but there's also another change. What you said is correct. That's one change. The other change is, yes, what Musab said. Instead of apply, it will be apply map. Okay. Instead of apply, it should be apply map. That is the another change. Okay. So now you can do it for many columns and a single time. This is apply map, and you will get. I don't know why it's showing red, but anyways, sometimes it does this. Okay. So here you have for C2, C3, and C9. See, for example, here 5.8, it should be 6, and you see it's 6. This 3.6 should be 3.5. It is 3.5. Same thing, you can check all, and it should work, okay, because the function is sum. So that's it. So we have seen now how to use dot apply and dot apply map methods of a data frame. And in those methods, we have seen how to use the simple lambda function, one-liners, or any custom function of your choice. And this will give you a huge power in preparing the data for the analysis that you are going to do in the next stages. Okay, so that is the basic programming, basic concept of programming that we need to treat to handle the data in Python. So of course, Python is a general purpose language, but what all we have seen in bullet number 2, the entire bullet number 2 was all about how to handle the data in Python. So when you read the data, how to read it and how to do some simple things in the data. And all this is related to pandas data frame. It is confined to that. Is there any other approach to read the data and handle? Yes, there are many ways. There are many libraries available out there, but the standard ones, that is something recognized and almost it is taken as a standard for data science, is the pandas library, and the data frame is the usual way to go, unless you have a big data. And for big data, there are different, slightly small modification, not much, but slight modifications. But for the usual data, this is the standard. Okay, go to Kaggle, go to KD Nuggets, and look at the nodes and kernels. You will find pandas being used. So that is the end of the first part of this chapter. Now the next part is data visualization. Data visualization is, you can say, a very strong component of data science. In the previous chapter, we have seen how a picture of the data can reveal many things about the data. If I give you 1 million numbers and you look at all 1 million numbers, you will not get anything. You will not get anything looking at 1 million numbers. But taking those 1 million numbers and getting a histogram, getting a box plot, getting a pie chart, getting a picture of the data can give you much more insight. Actually, it can give you lots of insights than looking at the number. Looking at the numbers will not give you anything. Even the experienced person, he will not get anything. There's no way we can get that. So that picturizing the data, that getting the graphs out of the data, this entire concept is called as data visualization. Data visualization. Okay, it is a graphical representation of the data. And we have lots of reasons why this visualization is important, and we have seen some basic visualizations like histogram and box plots in our previous chapter. Now when you have a data frame, which is in the previous chapter there was no data frame, so what we did, we used matplotlib library to plot the data. And that's the way. If you don't have data stored in a data frame, if you have data stored like an array, then go with matplotlib. That's the best way. But let us say the data is already stored in a data frame, which is the pandas data frame. Then how to plot? Well, if you have data already stored in a data frame, then you have much more easy ways to plot. Either you can go with the default plots that is offered by pandas. Okay, pandas offer you some default plots like data frame.hist, data frame.boxplot, and you have several plots. You can look for it and you will find. Okay. But there is a limitation that pandas doesn't give you much control. Also, it doesn't give you all types of plots. So there is a limitation on the plots that you can do with pandas. To enhance the plots, you also have another library, which is the Seaborn library. This is very popular library and also a very useful library for visualizations. And this is based on the data frame. So if you have the data in the data frame, you can use it as is without any modifications for the plots. The idea of the Seaborn library is very simple and straightforward, and you can plot many there are lots of varieties of plots that you can do. In pandas plots, not that much variety, but here you have lots of variety, and this should be more than enough for the basic data science projects that you can find. Okay, if you want to have specialized plots, interactive plots, yes, there are many more libraries, but this is the first step in coming up with a decent level plots. You could plot histograms, box plots, line plots, scatter plots, count, violin, and so many types of plots. Especially the pair plot is something, and we'll see all these plots, and I will highlight some of the plots that are very useful through through the examples, and maybe through the homeworks. You'll see how, and even in the project, you'll see how to use them, and these are very useful plots. We'll see. Typically, in Seaborn plots, you have different methods, no doubt, and for those methods, you have typical arguments. Usual arguments are which column should be on the x-axis, which column should be on the y-axis, and sometimes you would also like to use some coloring to differentiate the plots. Okay, differentiate means, for example, let's say you have let's say the data frame with male and female. You want to have, you know, box plot for males, box plot for females. Then you can use hue to differentiate them. Okay, so whenever you want to separate things, there are different ways, and one of the ways in the Seaborn plot is to use the keyword hue. And these are the basics, and we'll see, actually when you apply, we'll see how this work. Okay, and you have lots of customizations. These are the, like I said, these are the three arguments, keyword arguments. But apart from that, you have so many key arguments that you can use to customize the plot, and the customization can go on and on. Sometimes the customization is easy, but if you are very peculiar about certain things to do, then yes, you can do those peculiar things as well, which require some more, you know, effort. The Seaborn library is in turn based on the pandas, numpy, and matplotlib library. So Seaborn library is based on all of this. And if you didn't install Python through Anaconda, and that's what we said to install. Even in ICS 104, I believe you install Anaconda as your basic package repository, and everything is taken care. But if you are the guy who's using the PyCharm and you install everything one by one, then you have to install NumPy, Matplotlib, and Pandas, and then also Seaborn. Okay, so that's the chain. But anyways, we are using Anaconda, so you don't have to worry about this. All right, so that is more, you know, the visualization. There is less of theory, and you know, everything is numerical. Sorry, everything is practical. So let us take an example and see how the basic plots works. I have divided the example into two examples. One is the basic plots, some simple plots that you can be done, and then some of the, you know, not advanced, I would say, but some of the new styles of plots that you can do in the Seaborn. Okay. Let us you know, look at this basic 3.csv data, and let us see what we have in this data. Okay, so right. So here I read the data again. You know, data is in data folder, and the file name is basic 3.csv. In this data, I have, you know, well, we are habituated to this. Okay, data frame.head, right? Data frame.head will give you first 5 rows by default, and this is good enough to understand the data. But sometimes we would like to know more about the data, and then you can use the data frame.info. Data frame.info will give you for each column the way it is read in Python. Okay, the way it's read in Python. So it says that all these columns are objects. Objects usually are categorical. Data is by default, you know, he says if it is not integer or float, by default it will throw it into the object. That's the usual thing about, you know, pandas data frames. But if you know that no, there should be a specific one like categorical on these things, you can change. But you know, I would not say to do that. Just make sure that the numbers are treated as numbers, numerical are numerical, and everything else is part of object. Categorical, it's fine. Okay. And you can see correspondingly it's categorical, all of this up to here, and from here math, reading, and writing, these are all numbers. Okay, so you can use dataframe.head, but dataframe.info will give you the details about the non-null values as well as the data type, and the data type is something to look for before we proceed. All right, now it says add a new column to the data frame that represents the total score. What is the total score? The total score of math, reading, and writing scores. So here you have math, reading, and writing columns. I would like to add a new column to the data frame, which is the sum of these three. Now, to add a new column to the data frame, it's very easy. Okay, so yeah, let us say, let us use, sorry, basic 3. Yeah. So these are the columns. So to add a new column, what you need to do, very simple. You just say data frame new column equals to whatever value you want to give. whatever value you want to give. Okay. For example, let us say I want to fill. For example, let us say I want to say this data frame new column is one of the old column. So I will get. Oh, I should print it again. So I should get somewhere here new column, and the column, as I just give some random values. Okay, but this is as easy as that. To create a new column in a data frame, just write new column equals to, and then give the array or give the values for that new column. Okay, so here he is asking us to create a new column with the sum of scores. To do the sum of scores, all you do is just add those columns. Remember, columns, when you speak a column, it is like a series, which is nothing but very close to array. Okay, and when you have 2 or 3 numpy array, you just add them, and what you will get is the addition, not concatenation. I remember this example, right? You remember this from our first um, from our Python review chapter. Okay, so if I do this, I get concatenation. But if this is a numpy array, what will I get?
Sum.
Element-wise sum. So that's what we are doing here. Each column, and remember always, data frame is nothing but collection of columns or collection of series. A column is a series, and a series is it's a maybe minor differences. Series has some extra methods, but series is like array. If you can use array, you can use series. That's it. So this is a array plus array plus array. So it will just do the corresponding element sum. Okay. So you'll get this new column here. Let us execute one more time to see that. Okay. Now you see what happened. A new column came in. Why? Why did this new column come in here? Anybody remembers this?
You made it before.
Yeah. And let me run it again. Okay. So you see still it's there. So how to get rid of it? Well, I could delete it or just read it as the data again. Now it is gone. Okay. Now you don't have to read data in every cell. Once you read the data, it can be continued. Okay. But make sure that the things that you do here, which are, let's say, permanent changes in the data frame, will also be reflected here. So make sure, do you want the changes to be reflected or not? If you don't want the changes to be reflected, then maybe reread the data and then proceed. Okay? Be careful with that. All right. So we are done with, add a new column. That's it. Now he says to draw the histogram for all the columns. Histogram for numeric column, histogram for non-numeric column. So let us see how to do that. I'll just copy this code here. Right. So the same, sorry, oh yeah. So the same idea. You import the library. Okay. So import Seaborn as SNS. Okay. Now, why SNS? This is again a standard name for Seaborn, and actually it is no. There is some funny joke behind it. The why this name has been kept as Seaborn and things like that. It's coming from some series, and we will not go into that. But there is some reasoning, some funny, but reasoning. But this has become almost like a standard, like pandas PD, numpy NP. Matplotlib.pyplot plt. Seaborn is standard is SNS. Okay, SNS. Okay. So I'm going to import Seaborn as SNS. Of course, you have to also import Matplotlib if it was not done so. Okay, and also it's fine if you have this, but it's always better to have all the libraries imported before you do the executions. All right, so yeah, Now the same idea, when you have matplotlib plot, you start with plot.figure and end with plot.show. Plot.figure will create the canvas and plot.show will display the canvas. Okay, so the canvas is created. It's just that the size is not mentioned. If you want to mention the size, for example, let's say 5 by 5. Well, it is not showing, but it is here. Okay. Now, in that plot, I can use different commands. For example, I could have used plot.hist or plot, to do the plotting. But now we are using a different approach. We are using the SNS plot. Okay, we are using the Seaborn plot. Okay. So SNS, the Seaborn, has lots of functions, and for the histogram, you have hist plot. Okay, you have hist plot. And the way it's done is very simple. The way it's done is that if you have the data in data frame, it's very simple. So you just tell Seaborn, well, I'm going to plot for the data which is in the data frame, DF. So that will tell the Seaborn that whenever you plot something, look for this data frame. And in this data frame, I want to do the plot for the column math score. This is a numeric column. Math score is a numeric column. So I'm saying that on the x-axis, use this variable math score. That's it. You just give the name of the column. You see that how easy it is? You just give the name of the column. That's it. Because it's a numeric column, you remember for histogram you need bins. So here I'm just saying that to have 10 bins. You could also give your own bin style if you want, or you just give the number of bins as your number of bins. And now you get the histogram. Okay. Now you get the histogram. So to get the histogram for one variable, this is how you do. To get the histogram for two variables, that is a math score, and what else we had? We have, let's say, reading score. Okay, you get two histograms. Okay, so what basically is asking you is to draw all these histograms. Okay, now here I'm not using any subplots. We may be in the next chapter we'll use subplots, or in the future chapters. But right now we are just plotting one after the other, just learning how to plot one after the other. Now remember, if you remove this, okay, if you do it like this, then you will have overlap of the plots. Okay, overlap of the plots. Okay, now this overlap of the plots, sometimes is sometimes you want the plots to overlap, then yes, go with this. But if you don't want the plots to be overlapped, then treat them in a single figure. Now when you do this technique of using the figure and show, just by what we are doing by default, for every plot we are creating this plot.figure and plot.show. This is by default. But some of the Seaborn plots don't require this. By default they don't need this. So every plot in the Seaborn, okay, every plot in the Seaborn are of two types. One are the figure level plots. Okay, figure level plots, they don't require, whether you write here plot.figure, plot.show or not, they will create a new figure. Okay, they will create a new figure. Some of the plots are axis level plots. Some of the plots are axis level plots. What I mean is, if you don't write plot.figure, then they will not create their own new figure. They will plot it over the previous one. Okay, they will plot it over the previous. For example, here, when I deleted this line and deleted this line, okay, then what happened if he plotted, this is the picture here, he plotted this histogram over the previous one, over the previous figure. So those are the axis level plots. So whenever you want to have overlap of plots, make sure that they are the axis level plots. Okay, they are the axis level plots, not the figure level. Figure level plots, you cannot make an overlap. How to know? Again, how to know? Can anybody tell me how to know? Of course you can memorize, and at some point of time it will be obvious, but there is also another way without memorizing. Yeah, go ahead. Okay, help sns dot. So somewhere here, where is it? We have to see. Yeah, he's placing some of the information there. But yes, let me show you another way how to get it. There will be usually an option here in all these options about the axis. Yeah. So this could be another quick way. Okay, not it should be written here, and maybe when you use the Google help of this function, it will write it clearly. Okay, that it's a axis level plot. Okay, it will write it clearly that it's an axis level plot. For example, here it says C also, then it says disk plot, figure level plot. Okay, so you have some figure level, some axis level. So okay. Yeah, I know, but if you look at the Google help, the one from the Seaborn, it is much better in the way it's presented, and there it will be clear. But like I said, one quick way, and to show that, let me copy this plot here. Uh, One easy way is to check about the axis. If you have the axis keyword argument, it means it's a axis level plot. If you have a figure level plot, you will not find the axis. So let us check here. You will see no access. Okay, this is one I would not say smart way, but this is one rough way to do it. Okay, by the way, it also mentions here it's a figure level. So maybe in this help, if it's figure level, it's just saying it's outright it's figure level. I remember cat plot is figure level. Okay, so it says, yeah, so it looks like for figure levels it's saying it. Okay, Musab, sorry, Hassan, for figure level it's saying it outright, but for the access level, uh, it's not saying it. So this is one test. Okay, but anyways, as we proceed, we will remember most of it. Okay, we'll remember that some of them know the figure level and whatnot. Okay. And where is it? Where does it matter? When you plot separate plots, it doesn't matter whether it's a figure level plot or axis level. It has no concerns. Okay, no issues. Only issue is when you would like to come up with the overlap of the plots. And in our course, sometimes we do the overlap, but many times we don't do. So if you want to do the overlap of the plots, which plots you should pick? Figure level or axis level? Axis level, yeah. That's the only reason where you have to look whether it's a figure level or not. Otherwise, don't worry. If you are trying, simple plots one after the other, sorry, one after the other, don't worry about this. Only for overlapping, which is usually, the difficult part. That's where you have to think. Okay, all right. Yeah, you can change the colors. There are many things you could change. I think the color, you have an option. Again, I don't remember all the options, but yes, you can change the color. I think here you have color option. Okay. Let's say red, and you could, there are names of the colors. Actually, there are many standard names. Okay, so the spelling should also be correct. Yeah, so there are many standard colors that Python and SNS, Matplotlib, actually it's coming from Matplotlib, and they are recognized as is. Okay, uh, and you could use those standard colors if you like. Uh, it's not must, but what I try to do is I try to keep the data argument in the last. It's not must. There's no keyword argument. You can play shuffle anything anywhere, but I like to keep this at the end just for to make things easy for me, so that I remember that this is the data frame I'm using and it will be clear for me. But is it a must? No. And please follow whatever you know think is easy. Keyword arguments, you can shuffle them, and you can get. You could also make it transparent. I think there is an option, alpha. For example, if I want to make this transparent, alpha equals to 0.5, and it is slightly transparent. Same thing, let's do there. And please, we are discussing only few arguments, keyword arguments of this plot. We cannot, only few important ones, maybe you could say, but please look at some of these. And also this help is, I'm stressing on this help because this is for the exams. You can look here, but you are free at your home and during the quizzes also, or before for preparation. Look at the help of these functions from um, the Seaborn library itself, and it will give you the usage of different options clearly. Okay. All right. So that is how you draw one or two manually. Okay. That is how you can draw manually. What did I do? Yeah. That is how you could draw manually. Okay. That is how you could draw manually. But usually we don't want to do it. I want to draw it for all the columns. So can you tell me, how to write here names for each and every column automatically? Can you help me, suggest me? No, here, for example, here I have math score, one column, but I want to write here all the numerical columns. Okay, what all the columns that I have. For example, here I have math score, reading score, writing score, total score. So here, I don't want to write just one. If I want to write one by one, I could do it. I have shown you how to do it for math score, reading score manually. But let's say I want to do it not manually, I want to do it automatically. And if I have 40 columns, should I write all 40 times, copy paste the code? No. So whenever you have things that are being repeated, what usually you do in programming?
Put it on a loop.
Yeah, you go with the loops. Yeah. So I would like to put everything in a loop. So I'm going to say for something from, let's say not from in, something, and then this will be the loop. Now help me what those somethings will be. Okay, what those something should be and what that something should be.
So some things should be the title of the titles.
Good.
Like
So I
math
got two
score, reading
answers. I
score.
think they're right. So something should be the column names, right? List of column names. List of column names. So how to get the names of the columns in the data frame?
Can't you
Names.
read it?
Yeah, you could do. Yeah, you could say data frame dot columns. Okay, data frame dot columns. This will give me the list of columns. So let us quickly see what it does. It gives a list of all the columns. But histogram plot is for numerical columns. So how to get only numerical columns? Yes, based on data type. And do you remember the mechanism to pick column based on the data type?
by selecting.
Yeah. So select D types. Okay. Select D types. Okay. And there is this should be underscore. Okay. Select D types. And then what do you want? You want only numbers. So you could say include numbers. Okay. And you get numbers. Sorry. And you get these. Or you could say exclude object, because everything else is object. So exclude object and you get this. So you have two ways: exclude object or include numbers. Why I'm saying include number, not int? Because sometimes you have int, sometimes you have float. So for that, everything that looks like number is number, otherwise it's object. Okay. So I could use this as my something to get the names of the columns, and then that for each column I will do the plot. That's the simple. There's nothing really smart here. So now this something, what is this something? From this some things, what is this? And what is some things is
One
this list,
column?
right?
It's the math. It's each one of them, like math score, it score.
Yeah, so it's a name for each column. So something is the array. Sometimes I'm saying list, but it's the same. It's an array uh, of the column name. So this is like a column name. And where do you think I should fit the column name in this code?
It says x equals math score. Instead of that, put this here.
Yes, that's it. So now you have math score, reading score, writing score, total score. Okay. So that's the idea. And of course, here I just change the color. But here in this example, I used everything default. Okay. And that's it. Okay. This semicolon sometimes you place it here sometimes to suppress that extra access and these details. But you don't have to do that. It's fine. Okay. So that is how you plot all numeric columns. Any questions, any comments, anything about the code that you want? I hope this is clear, right? If you know how to do it for one, you just loop it, and now you know how to loop it. Okay, now you know how to loop it.
So
By the way, I did. Yes, go ahead, please.
are the numbers all the same? Because the graphs look all the same.
No, 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 not all the same. See here.
Okay.
It looks, because these are scores of students, and it should be like a normal distribution. In an ideal world, it will be a normal distribution. Okay. By the way, in the code, I just did something uh, strange. The numerical columns, num columns already contain the columns, numerical names of the numerical columns. So I did like twice, I think. So maybe it's a time to update. Okay. All right. Now let us look at the last one in a minute, and we'll stop. The next task is to look for the categorical columns. Okay, categorical columns. For categorical columns, you cannot use hist plot. You have to use count plot. Okay, count plot is like histogram but for categorical columns. So please remember that count plot is like histogram but for categorical column. So what are the categorical columns you have here? You can look at it here now. You have gender, you have okay, lunch, maybe easy names. So I'm gonna just take this and let's say lunch. So those are the categorical columns, okay, gender and lunch. And here I'm saying y equals to. If you want to do x equals to, you can flip it. It's up to you. So this is for on the x-axis you have gender. Here on the y-axis you have it. Okay, it's your choice how to put them. If you have long names, then I prefer, then it's better. You can try both, but when you have long names, it's better to have it in this style because the long names can come here. Here they will overlap. So and then you can rotate it. You can do all customizations, but without any customization, the simple thing with the long names is to flip the chart so that on the y-axis you have it. Okay, and you can also see things. Now this is like a yeah. I think this is. Let us check whether it's a figure level plot or not.
Count.
Yeah,
The T.
there's a T missing. T missing.
Okay, so yeah, so it is not a figure level plot, so you should be able to see them. So maybe let me create the alpha. Uh, oh, okay, I think I made a typo here. Yeah, so you could see them one behind the other, but at the beginning, because again, alpha is for what? For transparency. So making alpha 0.5, I'm making it transparent, and you could see the two one behind the other. So figure level plots always you can overlap, and let us see them individually now. So we can see one of them is big maybe, and one of them is small. There slight difference, so that's why when they overlap you couldn't see. Okay, so this is how you draw for one. For all of them, what to do now? All the categorical columns, the same style, right? You loop it. So here is the one to loop, and in the loop here again I did the same. It's not an error, but it's just repetition of things. So why to repeat? Okay, and here you can create. Actually, you can add so many customizations. Okay, don't worry about that. And once you execute it in a loop, you see here this is a column name that's been coming here. You see all the columns, and this is a default coloring. If you want to change the coloring, there is an option there to change the default coloring. And we can explore excuse me, we can explore these colorings during the homework things. Okay, all right. So I took a couple of extra minutes, but I hope we are in the middle of something. So let us stop here. We'll continue from here in the next class. This weekend or this Thursday or Saturday, I would like to have a help session on what all we covered. So if you guys are interested, let me know in the next class. Think about it, and if you guys are interested, let me know possible time on Thursday or Saturday. Any time is fine, morning, evening. Please, I believe you have a WhatsApp group, right?
Yes, we
Yes.
do.
Yes.